War. It's brutal, vicious, and dangerous. But in some cases, it's necessary. War is as old as humankind, but today's current conflict is unlike anything we've seen in history.
Our enemies are quite explicit about their intentions. They want to overthrow moderate governments and establish safe havens from which to plan and carry out new attacks on our country.
As terrorists fight dirtier, the military needs to be smarter. Some might even agree the war against terrorism won't be won on the battlefield, but here in America's backyard.
This is what R&D is all about. If we do our job, then we put weapon systems in the hands of U.S. soldiers that allow them to do their job. An enemy is eliminated and our soldiers come home.
Some of the Army's most valuable fighters are scientists, physicists, chemists, and engineers. They're testing new rocket engines, developing safer warheads, engineering unmanned aircraft, and testing the physiology between the mind and body. When it comes to the war on terror, it's technology versus guerrilla warfare. It's the science of war. This is Sergeant Tommy Riemann. This is Sergeant Tommy Riemann.
Sergeant Tommy Riemann, Echo 51st Infantry.
And this is Sergeant Tommy Riemann. Tommy isn't a superhero with superpowers, although some kids may see him this way. Tommy just happens to be an ordinary person who is an extraordinary soldier.
One of the coolest perks I've gotten to do is our very own action figure and trading card.
In 2003, behind enemy lines near Baghdad, his patrol fell under attack. Knowing the .50 caliber machine gun was the key to victory, Tommy threw himself in front of the gunner.
I used my body as a shield, and I got shot in the arm, the chest, and took 11 shrapnel rounds to my body.
For his gallantry in action, Sergeant Riemann was awarded the Silver Star, the third highest honor in the military. His bravery reached national status when he was honored at President Bush's 2007 State of the Union address.
For his exceptional courage, he has earned the respect and the gratitude of our entire country.
Today, Tommy is a celebrity, a real American hero. And most recently, he is featured on the cover of America's Army video game.
All that stuff's cool to me, but it means even more because I represent the Army. I represent the guys I fought and served with, and I represent something I believed in all my life, and now I get to be the face of it, and I love it.
In many respects, the face of the Army is one and the same to a test pilot. He's the man who assists in the Army's research and development efforts, testing new weapon systems and technologies. Like today, at the Army's missile firing range at Redstone Arsenal in Huntsville, Alabama, where he's just seconds away from launching a TOW missile. TOW stands for Tube-Launched, Optically Tracked, Wire-Guided Missile. Although the TOW is not new, the technology that trains Sergeant Riemann is.
I got a tank, maybe 300 meters.
Gotcha. On the TOW.
This is a crew-based trainer, so you're getting the crew-based interaction between the driver and the gunner.
It may look like a video game, but it's actually a highly advanced training simulator.
J. Olive, graphics engineer. Mission, train soldiers on TOW missile simulator.
So what they're doing right here is they're following a route. We have Tony driving the vehicle and Sergeant Riemann being the gunner. So they're looking for T-72 tanks, and what they're going to do is when they find one, he'll stop the vehicle or alert his gunner to the position of the target, and then he'll take it out with the TOW. The TOW is wire guided, so once he targets the tank. He can follow it if it starts moving laterally to him while the missile's in flight.
This simulation is designed to give the soldier the basic understanding of how to shoot a real tow missile.
Target destroyed.
Statistics have shown that proficiency and accuracy increase dramatically after being trained on a simulator.
We're using tactical hardware here, so all this is tactical. So we have gyros, fiber optic gyros in there that we can use to detect movement from the gunner. It can't get any more realistic unless we're out in the field.
The engineers and software developers are constantly working on the latest and greatest technology to save our lives, and without them, we couldn't be as proficient on the battlefield.
To test that proficiency, researchers have arranged for Tommy to fire a real tow missile at a real target. Not only do they want to record if he can hit the tank, but more importantly, they're looking for feedback from the soldier that represents the troops in the Army.
5, 4, 3, 2, 1, 5, 4, 3, 2.
A direct hit. Since the missile is guided by the thinnest of wires, it's crucial the gunner stays calm and doesn't make any sudden moves.
So what you have here is just a little bit of the wire from the tow. That's why it's important to keep those crosshairs on that target, because one shift this way or that way will snap this wire at that kind of pressure. So that's why with the trainer, it's so important that you do it over and over and over. So once you fire, that's a massive kick. It kicks off up to the left. Go right back to your target, onto the tracking gates. You hit your target, game over, soldier won.
The Army also has a similar weapon to the tow, but it allows for a soldier to fire and forget. It's called the Javelin, and it's a portable tube-launched missile system.
Once the gunner has locked onto the target, pulls the fire trigger, the missile at that point is on its own and it flies to the target by an automated tracker. The gunner can lay the launch tube down, disconnect the clue, and move to another fighting position.
And like the tow, Tommy has been trained on the Javelin simulator. So naturally, they want to test his accuracy on the real system too.
That was awesome. Yeah, we hit right exactly where we wanted.
Tommy is confident the training paid off.
I put the crosshairs right on the tank, and look at that hole. It doesn't get better than that.
That's the kind of accuracy Jay Olive and his team hope to achieve. And many believe if it wasn't for the intense training back in the lab, this precision may have been nearly impossible. It proves how video game-based training is a major component to defeat this new kind of enemy. When we come back, we'll meet Richard Hatcher, an explosive chemist.
This has got to be like the best job in the world. Blowing stuff up, stuff you thought about doing when you were a kid.
He's developing a new bomb that he claims will actually save lives. In the modern era, the battlefield has changed drastically. A generation ago, armored warfare looked much different from what we see today. Conventional warfare had tank versus tank and required missiles with armor-penetrating or fragmented warheads. But today, the enemies hide in caves or urban structures, so the need for the fragmented bomb has become limited. In response, the Army has implemented a program to build a new kind of warhead. And when the Army needs a new missile warhead, they call upon Redstone Arsenal. For over 40 years, Redstone Arsenal, located in Huntsville, Alabama, has been the heart of the Army's rocket and missile programs. Today, Richard Hatcher and his team of Army researchers are working tirelessly to develop that new bomb. It's the Army's goal to develop a bomb that destroys the target, but with less collateral damage.
The insurgents will hide within an urban structure. Adjacent to that structure, you've got perhaps a family. We want to be able to eliminate that insurgent and protect the family next door so that we do not create collateral damage.
Richard Hatcher, explosives chemist. Mission, develop enhanced blast explosive warhead.
This fragmented warhead is designed to propel shrapnel, or small metal fragments, outward and destroy the target. To demonstrate how steel fragments are effective, Richard set up steel panels.
This is 1/8" steel, and it represents something like, you could think about the thickness of steel on your car. It's very similar to that, probably a little bit beefier. But it's a good way for us to take a look at fragments.
To be safe, Richard and his team hunkered down in a bunker about 600 feet away.
Firing in 5, 4, 3, 2, 1, fire.
I think that was a success.
Yeah.
Okay, let's go down and take a look at what damage we did to those panels.
The test exceeds Richard's expectations.
In fact, I think the panels went a little further than what we thought they were going to go. I think originally I said we were going to rock them. We actually moved them.
He estimates the panel flew about 50 feet from its original position, and it's littered with holes.
Everywhere we see a penetration, part of that steel case came apart and ended up damaging the target pretty significantly. So this is a very good example of how you can eliminate a target with fragments.
The steel fragments even blasted a pristine wall of concrete.
And as you can see, fragments have hit these concrete blocks and done a significant amount of damage to it. The fragmentation has its place in the Army arsenal. They're very effective about eliminating a target. However, there is another way to do it.
And that new way? One word: pressure.
We're going to set up a second test. Same setup that you just saw, 2 target panels. But in this case, we're not going to be shooting a fragmenting warhead. We're going to be shooting a blast warhead, an enhanced blast warhead.
Army researchers have developed the Enhanced Blast Explosive, or EBX. Richard says this test should show a similar result, but doesn't expect to see any holes in the steel panels.
Guys, let's get started on this. Let's go ahead and get the other panels set up and bring the EBX warhead out.
The science behind the Enhanced Blast Explosive is actually quite simple. It's the same 8 pounds of explosive material as the fragmented bomb, but the EBX warhead contains aluminum particles. As the EBX warhead explodes, the aluminum particles become superheated and burn. As the particles burn, they gobble up oxygen, causing the combustion process to be extended, thus creating a tremendous amount of pressure.
Charged and ready. Firing in 5, 4, 3, 2, 1, fire.
That rocked. I think you hit it. It looked like, just on camera, that those panels went a lot further than the panels we shot on the fragmenting shot. So let's go down and take a look and see what it looks like. Oh man, take a look at that. Did you guys see where this panel flew? Take a look at this panel. I don't know if you can see it. Let me pull it down a little bit. Take a look at this. We've got to be at least 100 feet away from the target. Not a single hole in this, but we have moved this. You talk about killing energy, enhanced blast explosives, that's the way to do it.
A side-by-side comparison contrasts the effectiveness of both bombs. Although they look similar at detonation, the fragmented bomb riddles the panel with holes, while the EBX warhead propels the panel at great speed without penetrating one hole in the metal, thus demonstrating how pressure alone can destroy a target but with less potential collateral damage to the adjacent buildings. But the EBX is designed to be most effective inside a structure.
This simulates either a cave or a hardened structure in Afghanistan or in Iraq or any place else where we're fighting the enemy.
In Afghanistan, one of the many challenges is to penetrate the caves where enemies hide. Even if a fragmented bomb directly hits one room inside a cave, the steel fragments can't turn corners and enter the next room. So more than likely, the terrorists in the adjacent room will survive. Enhanced blast explosives should solve this problem. As the EBX detonates, the aluminum particles burn and soak up the oxygen, creating a shock wave of pressure that bounces off the walls. The shock wave turns corners, entering adjacent rooms, generating even more pressure. To test this pressure, they use a good friend they call Buster.
And this is the action room. This is the room that lets us know how effective enhanced blast explosives work.
They place Buster in the doorway to test the blast pressure by recording how fast Buster propels out the door.
Now Buster is made of something called dragon skin. And dragon skin matches the mass of human muscle tissue exactly. And he actually has a skeletal structure within it. He weighs about 140 pounds, and in his chest cavity, we have an accelerometer set up.
The accelerometer provides data on the speed at which Buster hits the wall.
Okay, I think that looks good, guys. Let's get back to the bunker.
Coming up, Buster earns his wings.
Anybody want to take a bet on how far Buster flies?
Charging and firing in 5, 4, 3, 2, 1.
In an effort to build warheads that destroy the enemy with less collateral damage, the Army's Richard Hatcher and his team of researchers at Redstone Arsenal in Huntsville, Alabama, are developing the Enhanced Blast Explosive. To measure the effectiveness of blast pressure, they place a homegrown dummy, affectionately named Buster, in the doorway. At detonation, they hope to witness Buster propel outward and slam into the strategically placed wall.
Anybody want to take a bet on how far Buster flies?
Over the wall.
Yeah, I vote over the wall.
Charging and firing in 5, 4, 3, 2, 1. Fire.
All right, guys, good job. I think we killed him. Let's go take a look. Where is he? Oh yeah, he's right up here.
It appears Buster flew right past the wall.
There's Buster's torso. Looks like we're gonna have to find the accelerometer. It's been popped out of the chest cavity.
Buster is blown into pieces. Calculations taken from the accelerometer show that Buster was traveling at 60 miles an hour when he hit the wall. And he was propelled from 0 to 60 in less than 1/10 of a second. Richard has to watch his step, or he may trample on a piece of Buster.
Total devastation. In fact, as you can look all the way out here as well. Take a look. Buster's jumpsuit was torn all to pieces in that event. He was never hit by a fragment. He was only destroyed by pressure.
A closer look at the high-speed video illustrates how Buster hit the wall. The force is so wickedly strong that Buster smashes at impact, yet his torso hurls another 100 feet past the wall.
This is what R&D is all about. If we do our job, then we put weapon systems in the hands of U.S. soldiers that allow them to do their job. An enemy is eliminated, and our soldiers come home. Thanks, Buster. Good job.
But developing a warhead is only half the battle. Delivering the warhead to its destination is a whole other ballgame. How are the rocket motors that propel the warhead researched, developed, and tested? Unbeknownst to many, the Army actually has their very own team of rocket scientists.
Dr. J. Lilly, aerospace engineer. Mission: develop rocket motors for small missile systems.
Today, Jay Lilly and his team are testing a rocket motor that has been in research and development for over 2 years. They specialize in motors that propel small weapon systems used by soldiers in the field.
Typically, they're small weapons that need to be stored for 20, 30 years under all conditions. They need to work in Alaska. They need to work in Saudi Arabia. Okay, let's go do this thing.
Today, they're testing its viability in an extremely hot situation.
It's been conditioned in an oven for overnight, and once we take it out of the oven, it starts cooling. So we want to get the shot done when it's as close to 140 degrees as possible, but the data is not valid.
Time is ticking, so they have to move fast. They have only 15 minutes to get the shot off.
They're making sure it's mounted on the stand properly.
To understand how a tactile missile motor works, we have to take a look inside. This solid rocket has a graphite epoxy case. Inside the case is a rubbery-like substance called a solid propellant, which is a mixture of fuel and oxidizer. When the fuel and oxidizers burn, the solid propellant is converted to a hot gas. This gas pressurizes the graphite case and generates thrust by flowing through the two nozzles.
Okay, it's been about 7 minutes. I think everything's going about as good as it possibly can. They're about ready to tie the igniter leads on. Everything looks good. They're buttoning things up. I think we're going to make it. So it's time to get up there.
Ready in 5, 4, 3, 2, 1.
The team is ecstatic.
Well done, everybody. Good job.
2 years of work for 2 seconds of success. That's the life of a rocket engineer.
It was a success because fire came out just the two nozzles and no other place. That's the first thing. Trace shape is pretty much square. Burn time was just about what we predicted, a little under 2 seconds. Pressure was right where we wanted it to be. It's a beautiful test. You can't make a better rocket motor than that. Absolutely gorgeous.
In the world of research and development, when a product is successfully introduced in theater, there is no greater reward.
Robert.
And that is true with the latest development in unmanned aircraft, in particular, the advancement and capabilities of the Shadow.
Getting ready to hit the start button and send this thing downrange, so let's get out of here.
The Shadow is the Army's latest surveillance plane built to spy on the enemy. Its most widely used mission is to catch the insurgents planting roadside bombs, or IEDs. IED stands for Improvised Explosive Device, and it's the #1 threat to American soldiers in Iraq.
It's IEDs on the road, you just don't know when or where it's going to be, and it can happen at any time.
IED, check your secondaries.
The Army hopes the Shadow can stop the planting of roadside bombs by catching insurgents in the act.
The Shadow UAV supports the maneuver brigade commander on the ground. It supports his reconnaissance, surveillance, targeting, and acquisition plan.
It does this by flying overhead at 15,000 feet. Unseen and unheard by the enemy, it uses a highly advanced electro-optical infrared video system to spy on the behavior of enemies below.
It is very accurate, and we're being watched right now. So if I were you, I wouldn't do anything stupid.
The video has incredible clarity. To demonstrate, the Shadow pilot watched the film crew drive up for this interview.
We watched you to ensure that you came in safely, and by the way, we think you drive a little slow, but we watched you driving into the gate and driving into this airfield, and we were able to tell, male, female, how long your hair was, what you were wearing. We couldn't exactly read the license plate, but we weren't that far off.
But what happens after the Shadow detects suspicious behavior? It can't shoot or attack, but the Apache can. When we return, we'll show you how the Shadow communicates to the Apache pilots. In Iraq, American soldiers stand up to terrorists and insurgents every day by facing the most feared weapon, the IED, or improvised explosive device. Army Apache pilot Ed Adams has served 3 tours in Iraq. He knows firsthand the challenges chopper pilots face in the fog of war.
The primary role of the Apache pilot in Iraq was to try to stop the IED emplacement. So what we would do is we'd do a lot of reconnaissance.
But they quickly realized they had a fundamental problem. Noise. The insurgents can hear the helicopters even from long distances and stop planting at the sound of a chopper. Then the Shadow was born. The unmanned aircraft was developed to spy on enemies from as high as 15,000 feet. They hope to spot when the insurgents plant the bombs. And now, the most recent breakthrough is the video-on-demand system called View It 2. It allows Army Apache pilots to view exactly what the Shadow is seeing in real time.
Roger, Apache 9, this is Shadow 5.
Today, Lieutenant Colonel Johnston and Chief Warrant Officer Adams test the new way to train Shadow and Apache pilots to communicate and engage threatening enemy behavior.
I do have your target. I'll be engaging this time. Missile away. Good missile. Target destroyed.
The Apache has the ability to tune those frequencies up and receive that video onto the helicopter. He has some button pushing that he can do to have those pictures displayed on his display in the cockpit. And now he's seeing what the UAV operator is seeing real time in the cockpit.
Missile left side. Any constraints?
The time it takes to talk an Apache co-pilot gunner onto a target can be minutes, 15, 20 minutes to make sure you're actually engaging what the UAV is looking at. If you have the video, that timeline can be cut down to minutes and maybe even seconds.
And it's Shadow 5, this is Apache 9. It appears all 3 individuals are dead, and we do have the target destroyed at this time.
Apache 9, this is Shadow 5, roger. We concur the assessment.
It cuts down on fratricide, cuts down on all the mistakes that could happen in the fog of war. So the situational awareness for those pilots is going to be increased tremendously.
Currently, View It 2 is installed in only a handful of Apache helicopters in Iraq. But the Army hopes it can increase that number soon, and in return, decrease the IED threat significantly. The Shadow isn't the only unmanned surveillance plane. Check out this little bird. At only 4 pounds, this portable handheld remote control plane allows eyes in the sky up to 4 miles ahead for troops on the ground. In the past, if commanders requested imagery of a town ahead, it would take anywhere between 12 hours to 3 days to get a response. The Raven has changed the way commanders make decisions on the field.
Luis Garcia, Raven trainer. Mission: train soldiers how to use the Raven.
Sir, in this bag, what we have is a UAV, an unmanned aerial vehicle.
Okay.
The Raven can be put together in less than 2 minutes.
The interesting thing about these wings is that it does not require any special rivets, glue,
right,
or what have you. All that's holding these wings together are a number of O-rings.
And if you're keeping track, the system has a total of 8 parts, last of which is the battery.
The lithium battery, rechargeable, allows a soldier to avoid having to use fuel on the system.
It has GPS and 2 video cameras, a front view and side view. And it's very easy to fly.
All clear.
Once in the air, any U.S. soldier can receive the video signal, the guys who launched it, or a team in the field miles away.
Taking the northwest house for Blue 3. I copy you.
Now, a soldier can use this laptop to actually adjust where the aircraft flies. There's points over here, and the soldier has these different waypoints that he can position in the area that he's flying, and then he can navigate to certain points just by pushing one.
And when it comes to landing the plane, it's easier than taking off.
The Raven is built to crash. And I've had this thing crash at the side of buildings. We replaced the payload, put it right back up in the air. I personally have systems that I've flown for about a period of 2 years without having to replace it. Minimal repairs here and there. The idea is for the soldier to be able to repair it at his level. Ready to go. Get it back up in the air. From the time the aircraft hit the ground to the time the aircraft was up in the air was about 3 minutes.
With over 900 birds in the hands of soldiers in Afghanistan and Iraq, it has literally changed the way troops conduct missions. For example, the Raven can change the way Humvee convoys carry out their missions. By deploying the Raven before they enter a town, soldiers can determine the odds of a hostile engagement. Understanding the risk of an engagement can make or break a mission, as can human behavior and decision-making.
Enemy on the right.
That's why performance enhancement specialists at Redstone Arsenal are teaching soldiers how to control their stress levels in hostile situations.
Focus straight ahead. Focus straight ahead. Stop. Watch those guys.
Keep your heart rate in control. Keep control of yourself. There you go.
Watch those windows. Enemy truck coming down the hill. Call in a shot to the tail gun.
These new techniques allow for smarter decisions and possibly saving lives.
All right, good job.
Joel Jameson, Performance Enhancement Specialist. Mission: monitor soldiers' cognitive coherence in a hostile engagement.
Using a device called the M-Wave monitor, Joel gets real-time feedback on how Kelly Sanders' mind and body are working together to achieve optimal performance in this hostile engagement.
This feedback will allow us to go back through the scenario and determine where she was excited, and allow us to, as we're going through the scenario, I can kind of remind her to go back to her teachings and try to calm herself down.
Watch those guys on the rooftop. Are they on the left? Straight ahead.
Focus on getting yourself in control. Focus on the task at hand.
Go.
Earlier, Kelly was placed in an eggshell-shaped chair for a lesson in control.
This chair is designed to isolate the sound to the individual, so they're completely focused on what they're thinking about and what they're visualizing on the screen.
This way, Kelly understands what is happening to her physically when her thoughts sway one way or the other.
What the spikes means is, at some point she started to maybe wander a little bit, thinking of something else that maybe got her a little bit more excited or got her a little more anxious.
And when that happens, Joel tries to teach Kelly breathing techniques and ways to refocus her mind on things that calm her down. And the best way to learn is on a simulator that puts Kelly in a stressful engagement.
She's using some of the tools that we've taught her in the classroom to try to get that mind-body connection, and for a moment there it went into the mid-range between the red, blue, and the green, but now it's back in the red and maybe.
And at the end, he evaluates her performance.
You okay, Hayden? I'm good.
She did very well. She started off, in obviously a nervous state and a heightened state, but she was able to bring herself back down.
I think I did okay. It was getting a little nervous there for a while, but but you know, all the shouting and all the action just kind of made me nervous, and I was able to listen to his commands and Joel's commands and kind of calm myself down listening to his voice.
This is just one more way the Army is utilizing physiological science to help train and improve soldiers' performance.
Without this technology, there's no way that I could know that I was stressing myself out. I did not know it until Joel's voice whispered in my ear that I was turning red on the machine.
Coming up, the future of war. New nanotechnology that has the potential to be developed into a rugged light bulb nearly impossible to shoot out. And an unmanned autonomous rotorcraft built to save soldiers' lives.
Autonomous means that the vehicle is flying on its own.
The future of war is hard to predict, but fortunately, the Army has a team of scientists who spend a majority of their work life creating the technologies for the future. Take, for example, the light bulb. Nobody thinks of the light bulb as a key component to fighting a war, but it's a very important one.
We need good lighting, but we also need lighting that doesn't break when people shoot at us.
Dr. Henry Everett, physicist. Mission: develop solid-state lighting using nanotechnology.
Dr. Everett is designing a rugged light bulb at Redstone's Engineering Center that can withstand the rigors of war.
And so we're working on solid-state lighting, which is lighting that's based on using semiconductors that can continue even when you're being shot at.
Most solid-state lighting, like LEDs, are red, green, or blue, but the Army needs white light. So Dr. Everett studies materials that can convert colored light into white light. And the material he uses is simply zinc oxide.
So, zinc oxide, that's diaper rash medicine. That's all it is. Zinc oxide is a very friendly material.
By pulverizing the zinc oxide, he creates a powder made up of tiny nanoparticles. A nano is short for nanometer, or 1/1,000,000th of a meter.
That means that each one of these little powders in here is made up of only a few hundred atoms across. Tiny, tiny. But because of the way we make them, they have special properties that allow them to convert UV light, ultraviolet light to white light efficiently.
And that conversion requires sophisticated physics experiments using ultraviolet laser pulses.
So we have a laser beam here, but you can't see it right now. I can make it so you can see it though. I'm going to pour out some liquid nitrogen, which will allow you to see where the laser beam is. See here? And this laser beam is coming onto a sample of zinc oxide nanoparticles. And you'll be able to see that when I turn on the full power, that white light comes off the zinc oxide.
To Dr. Everett, this dim ray of white light is a beacon of hope.
It may not look very bright compared to a light bulb, but you have to remember that the thing that's emitting the white light is a few hundred atoms across. If I make a lot of these, I can make it pretty bright.
But they're still light years away from developing an efficient, rugged light bulb. These are the early stages, with many more steps to climb.
The next step is to make these zinc oxide nanoparticles as efficient as physics will allow.
Efficiency is important with any new product, especially when it comes to saving lives in the theater of war. At Moffett Field near San Jose, California, the Army's aeronautical engineers are doing just that. The Army is developing an autonomous aircraft they hope will save soldiers' lives.
The kinds of things we develop here might be used in a military setting, obviously for attack or for something like casualty evacuation. If you had someone injured in an urban center and didn't want to send a manned helicopter in to rescue them because of the hazard.
Dr. Matt Worley, aeronautical engineer. Mission: develop autonomous rotorcraft.
This is Caliban. He's a remote control helicopter that has been converted by these mad scientists to have a brain and fly autonomously.
Autonomous means that the vehicle is flying on its own. There's no pilot behind it. It has a computer on board which provides all of the flight control signals that it needs to fly.
By using a laser rangefinder as its eyes, an onboard computer for a brain, and with over 600,000 lines of code, Caliban can fly all by itself, but not without certain challenges.
Anybody who flies a helicopter could tell you how difficult it is just to fly one by hand. Doing it autonomously brings all sorts of extra problems that you don't see with a fixed-wing aircraft.
And one of the biggest challenges is teaching it to land by itself without hitting anything. Today, Dr. Wally and his team are testing Caliban's ability to land in a fixed area that is littered with obstacles. Granted, they're just cardboard boxes, but with a little imagination, they're buildings, cars, and people.
Well, they're a range of heights. We're interested, obviously, in seeing as small an obstacle as possible. And so they've just been put together at 5, 10, 20, 50, 100, 200 centimeters high.
And then they free Caliban to flee the nest. Flying completely on its own, it moves toward the boxes.
So we give it longitude and latitude points, and it basically lays out a nice, smooth, three-dimensional route through those points and flies that route, follows that path.
And when it finds the boxes, it stops and stares at fate.
Right now it's hovering about 20 meters off the ground, and it's using the laser scanner to measure the location of the boxes and find a safe landing spot.
Computer-based or autonomous systems are generally more precise than a human-piloted aircraft.
So you'll notice it's very stable when it's in a hover with the GPS system and navigation system that we have. It'll hold a position within 5 or 10 centimeters when it's in a hover.
And when Caliban is satisfied with what it sees, it makes a move.
Basically, the vehicle scanned the area now, and it's found a safe landing spot, and it's going to come down and try to land on that spot.
A perfect landing.
So the vehicle landed where we wanted it to, clear of all those obstacles. It found the spot in the center, and it looks good. Let's go have a look.
Avoiding cardboard boxes may seem juvenile, but Matt has already tested Caliban at an obstacle course modeled after an urban setting. He says they're not too far from Caliban hitting the major leagues.
Oh, this technology is fairly close in. It's, a few years' time, you should see this in the field.
An autonomous aircraft flying through dangerous war zones to save lives. A warhead that limits the deaths of innocent civilians. And 3D graphic simulators training young soldiers to be battle-ready before they leave American soil. In Iraq and Afghanistan, United States soldiers face a new kind of enemy.
They're smart. Every day they watch you.
The only certainty is uncertainty.
You got to make a decision real fast, real in a hurry, and you got to hope it's the right one.
You got to be on your toes and be on your A game.
It gets pretty hairy.
Knowing where you are and what's around you is called situational awareness, and the newest in warrior technology is going to give it to them. With the flip of a helmet-mounted display and the click of a heavy-duty mouse, they've got high-tech situational awareness that's crystal clear and lightning fast. It's called Army's Land Warrior System. State-of-the-art navigation and communication at their fingertips.
I felt like RoboCop when I first put on the system.
You kind of feel like Universal Soldier a little bit.
Some have their doubts at first.
I don't want to have anything to do with this.
But the proof is in its performance.
When we hit ground and we flipped that system on from day one, it was like, I don't want to do a mission without this.
Follow the Stryker Brigade combat team as they turn from cynics to believers, with the newest edition of the Land Warrior system. Next on Science of the Elite Soldier. This is war. But 20th century warfare has had its day. The future of war requires a new type of soldier.
Saber, go! Go, Saber, go! Moving!
And for the 5th Stryker Brigade combat team of the 2nd Infantry Division, this is only the beginning. They're in Fort Lewis in Washington State, training for their next deployment. 5-2 is close to 4,000 soldiers strong, and every one of them is preparing physically and mentally for the task ahead. The 5-2 will not be packing lightly. In addition to an impressive fleet of 8-wheel drive Stryker combat vehicles, they're also taking along the highly anticipated Land Warrior system.
Land Warrior is a combination of the computer on your desktop and the cell phone you carry around, except we've now built it in such a way that a soldier can wear it.
It may look like a nondescript jumble of boxes, cables, and antennas, but when all the pieces come together, the Land Warrior system is lightweight, worn right over the soldier's body armor, and becomes a total game changer.
It removes this arduous process of figuring out where the heck you are and keeping track of where you are.
Set! It's already set!
In combat, the Army soldier has to have situational awareness, or SA for short. He has to know where he is, where his friends are, and where the enemy is.
I cannot verify the number of enemy.
Until recently, there's only been one tried and true way for a ground soldier to have situational awareness on the battlefield.
You had a paper map, and you had a compass, and you had a piece of clear plastic over your map that had lines drawn on it and figures, which we call graphics, that were referenced for everyone who had that could say, okay, go to objective cat or so forth.
We will attack with 2 platoons on line and 1 in reserve.
You read the map, you knew where you were, there's the road, there's the hilltop, okay, I'm about here, let's see, where are the other elements of my organization?
The enemy holds the ridge with an estimated reinforced rifle platoon.
And so that's the way you did it.
Well, that's it then. I'll be at my OP at 0815 for final coordination.
Usually you were right if you knew what you were doing. Sometimes you weren't.
Thanks to the Land Warrior system, these soldiers can keep their maps and compasses tucked away.
Any questions?
The Land Warrior is a cutting-edge navigation and communication tool that delivers total, real-time situational awareness.
And the big piece of it is giving everybody a common operating picture. Everybody knows where they are, everybody knows where their buddies are, everybody knows where the enemy is.
Land Warrior technology starts with the basics. Global positioning capability shows the soldier exactly where he is on the battlefield. However, there's a lot more to it than that. The system uses a secure network to tie all the Land Warriors together. Each soldier's location is on the network so everyone can see him and he can see everyone else.
Grid 370147. Danger close. Over.
It's this network that makes life easier for the soldier and tougher for the enemy.
You see the enemy, you know where they're at. You can tell everybody else in your organization by going to your control unit, plotting the position where you see the enemy, and put an icon on your map, a symbol for where the enemy is. That symbol gets picked up by your radio and distributed to everybody else in about 2 milliseconds. That's one of the amazing things, is the ability to share that information across the network very, very quickly.
And in case an enemy hacker gets a buzz to infiltrate the system, they'll learn a new word. Buzzkill. The system is hack-proof. And worst case scenario, should a soldier be captured while wearing an active Land Warrior unit, the Army's thought of that too. But it's classified, of course. The integrated network is nothing new. It's been in Army vehicles, Humvees, tanks, helicopters, and Strikers.
It has a digital capability that's integrated into the vehicle and integrated across the brigade. So when you're driving the vehicle, you can see where you are, where your friends are, and where the enemy is. That is a decisive edge.
But with the Land Warrior, the dismounted soldier has a complete system attached to his body, and that changes everything.
It's the guys on the ground that are going to get the job done. And if you give the guys on the ground the tools to be faster and, you know, more accurate and more lethal, okay, that's where we need to go. And I think that enough people have gotten the point now and have seen it that they won't go back.
You're the first unit in the United States Army to be equipped with this kit. You're going to tell us what's good about it, what's bad about it. You're going to rewrite Army doctrine. You're going to rewrite the way we fight.
The first unit to put the Land Warrior system into action was the 4th Battalion, 9th Infantry Regiment, based in Fort Lewis. The Army gave them the task of testing it, getting it combat ready, and then using it in Iraq. Early on, the 4-9 had some doubts.
I was a pretty big advocate against the whole Land Warrior program when we found out we were going to take it. And I was like, oh, man, it's another 10 pounds of stuff I'm never going to turn on.
I was like, oh God, I don't want to have anything to do with this. Wasn't reliable enough. There's too many issues with it. So I was the first to say, no, shouldn't take it with us.
At first, I really couldn't grasp the concept of what we were trying to do, the big picture. And then once we got deployed and we were actually in combat, and things are real, you can figure it out how this is a combat multiplier and how it actually can save lives, make you faster and more effective.
The 4-9 spent 15 months in Iraq, from April 2007 to June 2008. Their job was to quell the raging violence in the heart of an al-Qaeda stronghold just north of Baghdad.
When we hit ground and we flipped that system on from day one, it was like, I don't want to do a mission without this. The ability to provide situational awareness on a battlefield, and especially a battlefield of today where it's unconventional warfare, you can't replace that. It's irreplaceable.
It was a great tool. It was something that we used every day, every time we went outside the wire. We did a lot of time-sensitive targeting raids, if you will, that were based on perishable intelligence. And so you had to go right now. Briefing your guys very quickly and being able to drop into some place at 3 o'clock in the night when it's, 3 o'clock in the morning, I should say, when it's pitch black, and someplace you'd never been before, and to know exactly where you were, exactly which building you wanted to go to be able to pinpoint things and just move out extremely quickly was a huge advantage to us.
We actually got off a helicopter one time, and a squad was probably about 500 meters away from the actual objective area of the house. But the house was surrounded by about 75 different houses with a maze to go through. And the squad leader plotted on the map. We had the exact grid. We knew where we needed to go. He just ran, and literally full speed, that squad ran through the maze. In like 30 seconds, they were at the house and took it down before anybody could react. And when he did, he took down the target, he captured the individual, he ran out the opposite direction, called the helicopters as he was coming in, got picked up, and flew away. We went back the next day to see what the reaction was of the people, and they said, we heard something, but, the only thing we knew was that the terrorist leader that was in our area is gone.
From the time they arrived in Iraq to the time they left, the 4-9 saw enemy attacks go from 150 a week to about 10 a month. Without question, the Land Warrior system was instrumental to the soldiers' safety and success.
But we drive right up to the target, we knew where we were going, and the guys were getting off the trucks and running to these targets, which is the way it has to be. It has to be quick and down and dirty. And we snatched a lot of really important people. I think in a month, we caught 58% of the entire brigade's targets. And that was just one company of guys. Because we were able to use these icons, we were able to use the Land Warrior. It was doing its job, and it did. It made us much faster, and flash to bang time was significantly reduced.
When I got ambushed, it was the L-shaped ambush. So for us infantrymen, an L-shaped ambush is pretty much one of the worst case scenarios you can ever run into. You're getting engaged by 2 machine guns at the same time, and you're pinned down. I could not gain fire superiority, but Because of Land Warrior, I was able to build an overlay of the city, and I was able to find a safe house. So I maneuvered my squads by bounding back, breaking contact, and the quick reaction force was able to link up with me, and were able to destroy the enemy because of Land Warrior.
The clearest evidence that the Land Warrior system made a difference in Iraq is this. The 4-9 came home without a single friendly fire casualty.
The infantry, in my opinion, will undergo a revolution with this. It's got to be this way. We have to do this.
When we return, see the first generation of Land Warrior and how it has evolved over the years. Plus, science fiction becomes reality when some mad scientists play mind control. Next on Science of the Elite Soldier. Today, the Land Warrior system is becoming a crucial asset in the fog of war. In fact, it's so valuable, the 4th Battalion, 9th Infantry Regiment took notes and returned from Iraq with a number of suggestions to improve the system. Those upgrades are part of the leaner and meaner Land Warrior 2.0. Batteries are included. It comes with fewer cables, a more durable control unit that fits in its own holster, a texting keyboard, and FM communication that's now easier than ever.
36, patch 6.
A new feature that we put on here is the push-to-talk, or the PTT, that the soldiers use to get their FM comms. They usually have a push-to-talk that's up here. Squeeze that, talk into the mic. Here, with this push-to-talk here, allows him to push this, and he can send his FM comms right out there.
But the Land Warrior was never this sleek and tidy in the first edition. Back in the 90s, when it was first developed, it was as awkward as those bad sci-fi movies.
We'd like to help you fight your enemy. Can you tell us where he is?
And with every bad movie, there is a director with an unusual vision.
I think we've got to do something. We will.
Fortunately, the maker of the Land Warrior had a vision too, but it was in the shape of a video display on the helmet, a much cooler concept. Near the scope, a camera was mounted on the soldier's rifle that fed video to his eyesight monitor. Of course, with a night vision option. To switch views, a mouse was positioned next to the trigger finger.
It's on the right side, as well as the left side.
And finally, a body computer strapped to the back. The original Land Warrior system weighed 25 pounds. That's 3 times heavier than today.
To me, where the technological accomplishment is taking what's built in the commercial world and making it rugged and low power and small enough that a soldier can wear it and it doesn't get in the way of everything else he does. He doesn't have to take it out of his pocket or off a clip on a holster on his belt like he does a cell phone. It's just there. And so it's out of his way. It doesn't get in the way of his weapon, his ammunition, his water, and his eyes, his other senses that alert him to what's happening around him in the battlefield. That's the science.
That's where the lines lead to, all right.
And with science comes that kitschy sci-fi foresight many writers and filmmakers love to embrace.
The research program is going according to plan, but our suits are so heavy that working is difficult.
In fact, back in the 1990s, one documentary producer took creative license to foretell the Land Warrior system of 2012.
Okay, I'm seeing the position and ID on everyone. They're not doing much. It's gotta be the target. Let's give them a picture.
7 November, go.
Bingo, that matches the intel.
But a camera view from the rifle wasn't enough. The producer dreamt up flybots to get closer to the enemy.
Here's what I'm seeing, Commander. Flyfix coming your way, sir. Flybot system confirms. We have a biological weapon.
Flybots have been a dream of science fiction creators for some time. Take, for example, this artfully crafted film from 1959. Back then, flybots were outlandish, but today, it's not so far-fetched. One way to give the land warrior soldier eyes behind enemy lines is mind control. The Defense Advanced Research Projects Agency, or DARPA, is developing remote-controlled beetles. This is not a joke. Using real, live, giant flower beetles, scientists implant electrodes and send electronic impulses to its brain. They can start and stop the beetle on command. Although the Land Warrior system can't control a bug with the same ease as changing TV channels, it is already equipped with remote gadgets that are pretty cool.
I can connect to unmanned ground vehicles, the small robots that they're building in other Army programs.
Like the MarkBot 4 robot, used to investigate suspicious objects such as IEDs. The MarkBot is able to observe objects at distances 300 feet away. For objects closer, but hard to see, there is the pole cam. And within throwing distance, there is the toss-it-as-hard-as-you-can wireless camera system called the Dragon Egg. This grenade-looking device transmits a 360-degree field of view video back to the network.
I can also receive other sensor data like gunfire detection sensors.
This unique acoustic device called the Boomerang can detect and locate a gunshot from a possible sniper.
So if somebody's shooting, not only do I hear it and I know it's happening, but now in my display I get a sensor input that says, here's where the shooter might be. And it's pretty accurate.
Putting eyes beyond the ability of the soldier is key to today's war. But nothing works without the meticulous engineering inside the pack. It's crucial not to forget the core of the system is a compact and ruggedized computer that sports its own hard drive and a very capable low-power processor. Without that, the system has no memory.
This is the brains of the system. Everything works through this system right here.
Right next to the computer is the network radio.
It's not the normal handheld radio you've seen on televisions. It's a network data radio. It lets you do voice using IP protocol, but it also does a lot of data communication, so you're constantly receiving messages from your commander, from your subordinates, from your peers about where am I, what are they doing, and what do they see on the battlefield in front of them.
The entire system is powered by one lithium-ion battery, which can last up to 12 hours. Soldiers always carry a backup, and they are trained to quickly hot swap the batteries so the system never has to shut down.
You can either take the whole vest off to do it, but if they're in the middle of a firefight or maneuvering, they'll have their buddy do a hot swap for them.
Coming up, the revolution begins. The new generation of skeptical land warriors go into action.
Hey, is this building clear? It's green on the things. All right, let's go.
When science of the elite soldier returns. The Army's Land Warrior system is a proven game changer.
Because it makes us a better fighting soldier. It makes us more effective on the battlefield.
It cuts down the mission planning time, the mission execution time, because you don't have to stop and look at things. You don't have to talk on the radio as much. You can see where you're going, you can see what you're doing. It makes us faster, more lethal, and it gives, leaders confidence in what they're doing.
Meet me in the center.
A state-of-the-art navigation and communication apparatus, the Land Warrior system is becoming essential to the fight.
Before we deployed, nobody wanted it. After we got back, now they're all crying to get it back, to go back to Iraq with it again. So it does turn some heads after you use it.
It's going to take a while to get used to freaking aviation.
The Army's 5th Stryker Brigade Combat Team, 2nd Infantry Division, will very soon be putting an ample supply of Land Warriors into theater. They're undergoing 4 final days of intensive training with the equipment and learning all the ins and outs.
You guys have all kinds of different maps you're looking at, right? Come over here and you're going to click on the crate overlay button. These here are your categories for symbols. The overlay tool palette is restricted to 2525 Bravo symbols. You can right-click the thumbnail and set that map as a default, so when you open up your overlay editor, that map always comes up with the overlay editor.
During their training, soldiers learn, among other things, how to read what's in that cyborg-like helmet-mounted display, how to maneuver through the system software, how to change the batteries, how to handle the control unit, and even how to text.
Soldiers can text now, and we actually find that young soldiers like to text a lot. They'll talk less and text more.
It actually has two features to send a text. You can actually flip open one side, and it's like a little keyboard, or you can use the mouse and just looking through your monitor. It has a little virtual text in there as well.
Final grid location, Echo Tango 369er.
What I like most about it is everything's readily accessible right at the touch of a button. You can switch automatically from what's going on out on the battlefield to sending messages. It's an all-in-one system that's rolled up.
It's just one more thing to learn how to use. There's a lot of technology in the Army now, so we're adapting pretty quickly.
You can see everything where it's online, has maneuvers coming through, so everything looks great.
Main challenge is making sure that the soldier is comfortable with the equipment, can effectively operate it, keep themselves in the fight. Once they get their hands on, then they see their buddies on the screen. They know how to operate the equipment. They're a lot more comfortable, a lot more confident.
The controls are different than the normal computer, and the software is kind of different. You have to be able to control things. One of the, for example, there are lots of choices, but we make them only 2 mouse clicks away. You never have to punch the button more than twice to get to where you want to do. But they pick it up very fast. They master all the controls, and it's really amazing to watch them walk out the door and go, yeah, I got this.
It takes some time to adjust to all the new gadgets, especially the helmet-mounted display, or HMD. Inside is an eye-catching 1-inch square monitor that packs the same resolution as a 17-inch flat panel.
Roger that.
Is it calibrating?
Calibrate now.
Okay, just hold still. And then it's going to say calibration is complete.
For the most part, they seem to warm up quickly to the technology.
I come from the younger generation that grew up with Nintendo anyway, so this is pretty much an easy jump.
It's actually been pretty easy. It's a real simple system. Whoever designed it kept the acronym KISS in mind, keep it simple, stupid. It's designed for people like me.
The technology is very cool, but it does have a few side effects.
The toughest thing getting used to is probably the weight. We were kind of worried about the weight.
I think it will be useful, but I don't think it's worth the weight useful.
The Land Warrior system weighs 8.3 pounds. That may not sound like a lot, but 8.3 pounds is more than a loaded M4 carbine. In fact, it's as heavy as a gallon of water. The weight of the Land Warrior is distributed evenly on the body, but any soldier who is on foot for several days at a time, in mountainous terrain, in high altitude, is going to feel 8.3 pounds.
You got to work out. You got to stay in shape because it is heavier, and with combat load, you're kicking anywhere from 60 to 90 pounds, depending on the mission. So you got to be ready to tote the weight, but that's what combat is.
Historically, soldiers carry a lot of weight, but with a computer strapped to the pack, soldiers haul 3 times the weight they did in World War II. And it's possible that this gear, technology, and constant barrage of information could cause overload.
Guys actually think it's a distraction because they always want to look in there and see what's going on, but you learn to have a balance. And once you learn how the system works and what you're actually looking at, what everything means in there, it's second nature.
Clear.
How do soldiers keep it all straight?
You don't keep that eyepiece in your eye all the time. You only use it to situate yourself, to find references. So when you're walking or doing a patrol, you're walking. But if you need to key in on a certain thing, like where is the CLC house? Where is the enemy? Where is this Iraqi police station? Oh, I've got it marked on my map. Let me go look. Got it. Continue mission.
Because the battlefield can be a lonely, frightening place, soldiers naturally tend to group together. With Land Warrior, they have the confidence to spread out.
So the first thing you see when they start using Land Warrior is that they disperse and they stay dispersed. They don't feel like they need to have eyeballs on their buddy. They're not in line of sight, because I can look at my display and see where my buddies are. I'm very confident that they are where they show up on my map, and I don't have to pull a map out to find them. They're right there.
In a squad of 9 soldiers, only 3 wear Land Warrior systems, the squad leader being one of them. The other soldiers in the squad stay within eyesight of the leadership at all times. And it is understood that each blue circle on the grid actually represents 3, sometimes 4 soldiers at that one location.
Clear? Right, clear. Objective is clear. We are set 360 security.
After running through different mission scenarios, the soldiers realize very quickly the advantages the Land Warrior system brings to the fight.
When you're looking for high-value targets and stuff like that, normally you've got pockets full of layouts and pictures, and you're fumbling through it, especially in the middle of the night. It can be real rough pulling out flashlights and showing all the guys what somebody looks like. This way you just turn your little screen around and, you know, or hey, this is where we're going. It makes it real easy for dissemination of information.
It has so many capabilities. As far as like clearing town and whatnot, you can see what buildings you have left to clear, which buildings have been cleared, if they're safe, if they've had enemies in them. It's a real nice system.
With this, I can communicate with some of my battle buddies, my leadership. They can tell me what they need, and I can also see where they are on the battlefield. And that right there is an absolutely fantastic tool.
Coming up.
So you got a bad guy in number 2.
It's a full dress rehearsal for combat with a high-tech twist.
Maybe they thought, you know, in combat, you'd be sitting there using text messaging.
That's next on Science of the Elite Soldier. At Fort Lewis in Washington State, Apache Company is booting up their Land Warrior systems for a final day of training.
With this, we're going to see, you know, if it's going to actually work or not.
They're about to put their Land Warriors to work in a simulated combat situation. The mission: navigate through dense forest and heavy brush to locate a small cluster of buildings. Then, overcome enemy fire, capture or kill a high-value individual known as an HVI, and secure the area. Company Commander Edward Graham is overseeing today's operation. He wants his soldiers to make full use of the Land Warrior's navigation and communication capabilities.
I think this equipment is going to help us understand the big picture a lot better and be able to communicate more effectively. It takes a little bit to get used to, but you're feeling more natural with it the more you train with it.
Earlier, Captain Graham put in the time building a mission data package for today's exercise.
I'm trying to get everyone a little bit time and experience on Land Warrior and give them actually time to enter and clear. Also, just to get you guys prepared. I know for my case, I got some new platoon leaders.
His MDP includes details about the mission, maps, satellite photos, reference materials, and most importantly, an operations overlay that tells the whole story.
The commander is coming up with his plan as far as how he wants his overlays drawn, so everybody has a common operating picture.
My intent for this mission is it's all about Land Warrior.
He can choose units. He can assign affiliation to those units. Let's say that he knows there's enemies out there, or maybe he doesn't know. He can change the affiliation of the symbol to show unknown, friendly, enemy, or neutral. Then he can choose what symbol he wants to draw. He can draw phase lines. He can draw targets. He can draw units. There's many categories to choose from.
It helps speed things up and makes graphics common for everybody. You know, the only issue is you got to have time to be able to do that planning.
We're going to upload this MDP into our own Land Warrior ensemble.
The sizable mission data package goes from a laptop onto a thumb drive, and from that thumb drive onto each soldier's Land Warrior system.
Okay. Just plugged in for downloads.
In time-sensitive situations, smaller files like a single overlay are sent instantly over the Land Warrior network. In either case, the soldiers get all the information they need very quickly.
And this is the graphics in which they put together for their mission yesterday. So this gives them their boundaries, their corridor in which they're moving in, their axis of attack, where they're putting their support by fire positions and all that in.
As the company reaches their drop-off point deep in the forest, they see that Captain Graham's reconnaissance element has already spotted enemy positions and marked them in his system.
We're sending these digital reports back to Captain Graham. From there, He's making decisions on the plan that he initially came up with.
Black 6, Apache 6, do you have eyes on from support by fire building 4, the contact being made?
So it may alter, depending on how the enemy is positioned, it may alter his plan, and he may have to readjust to maneuver forces in a different location.
Once we get to 27, we'll set up a support by fire on 28.
Everyone wearing a land warrior can see those enemy positions and knows what's coming.
They've actually physically identified a bad guy in this building here, 1 in 25 and 1 in 27. So they know when they go to do their attack, they know that they're going to encounter bad guys.
We have no one on 26 or 25.
Throughout the mission, soldiers can change who or what they see in their helmet-mounted displays whenever they like. It just takes a couple clicks of the mouse. They can review mission details, zoom in, zoom out on the target, see just those land warriors in their own platoon, or see everything on the grid at one time, including combat vehicles.
Their vehicles are being shipped right now, so they don't have any strikers out here, but they would be able to see their strikers on this platform also.
Company Commander Captain Graham looks at the big picture.
I was able to look online on my little screen, heads-up display, and see that my soldiers were in place. Confirm with the radio transmission, that's exactly that they were set and ready. I already knew they were where they're supposed to be because I could see that. Roger, waiting on you. Increase the tempo, let's go.
Building 7 is clear. 1 enemy KIA. I'll copy.
Roger.
Yeah, the church is, or the mosque is no fire area for us, so I mean, there could be bad guys in there. And then the building without a number could be bad guys in there.
They're not all.
What, do you want me to hold them up, sir? Right there at the seal?
Yeah.
Soon after the soldiers begin their assault, they are able to mark their progress on the grid. Thanks to Captain Graham's land warrior training, the men have a firm handle of the color codes on their display and how to react to them.
It saves a lot of time if you know where we've already been and where we need to go. And also the same thing, knowing which buildings, especially as we moved in later, knowing which ones we could just push past because they had already been done. Normally, it takes a little bit more talk.
I need you to tell me 6 and 7 are secure, cleared, and that no one on that objective meets the description of the HVT.
Still, the hunt is on for that elusive high-value individual. And when Captain Graham receives new information about the HVI's identity, he lets his thumbs do the talking.
We were targeting one guy. We found out later that that's not the individual we're looking for, so I was able to put a frag on information out, something called a FIPper, basically like a text message. You would have thought, in combat, you'd be sitting there using text messaging, but it's pretty good. Roger, break. Mohawk 6, Apache 6, you're clear your abilities 1, 2, and 3 this time.
Does he have any markings on his left hand?
Before long, the bad guys run out of places to hide, and the company takes down the high-value individual.
Roger, is he upstairs?
After they either kill or capture this individual, they'll go ahead and take a photo of the individual and send it back to the chain of command and import it in and then actually send it out like an email. And they'll verify, yes, that is the guy we were going after.
Obviously, we had a lot more people out here than was needed because I'm trying to get all the soldiers used to the equipment before we deploy. But as far as tempo and being able to track and understand what buildings have been cleared, where friendlies are compared to the enemy locations, yeah, it's pretty impressive actually when we get to it.
Hey, let's go.
In the end, this exercise is an eye-opening experience for the whole company.
It was a good improvement. You can see a lot of things occurring on the field that you couldn't, if you were behind a building.
I feel good about it due to the fact that in case we get far enough away from each other where we can actually say, hey, look, there's guys 200 meters that way of my friendly element, and I'm standing here watching this house. I need to be able to know when they're going to be approaching or when they're going to be there. That way I don't shoot with my friendly soldiers.
They have a sharper understanding of how to adjust going forward.
It's hard. It's a hard transition between moving your men on the battlefield and constantly checking your little computers.
And at times, confusion happens.
Are we in building 7?
This is building 7 right here.
This is building 7. Hey, sir, is 5 clear?
What's that?
5 clear?
5?
Building 5?
I think he said building 5.
That was 6. We just came from 6.
That's 6. This is 7.
You gotta find a happy medium between all that awareness that it gives you and being, trying to kill the bad guy, because that's, ultimately that's what we're here for. So we'll get it down.
3-6.
Captain Graham is ready for what lies ahead.
Yeah, I feel confident. My soldiers are well trained and well prepared. I got very professional enlisted soldiers. I'm very good at their jobs, a lot of them with combat experience. So I'm comfortable. I'm ready to go over there and complete our mission.
And even though the Pacific Northwest is 6,000 miles and another world away from Afghanistan, these soldiers know the drill.
Everything that they're doing here, they're going to do over in Afghanistan. It could be a mountainous, could be low rolling hills. It'll work over there. Guaranteed. Been there.
Coming up, a trade show that has all the future gadgets.
When I was in Iraq last time, we didn't have equipment like this, and it was hard to see what we was getting ourselves into.
When Science of the Elite Soldier returns. Every year, the Association of the United States Army puts on a trade show to showcase the hottest technologies in future combat. This year, the buzz is swarming around robotic tech toys that take the soldier out of the hot zone.
What has drawn a lot of attention, particularly this year, has been the employment of robotics and sensors, particularly unmanned ground sensors and unmanned aerial sensors, because they are providing to soldiers in Iraq and Afghanistan real-time intelligence that can save lives and also help conduct a military mission with far more precision than we had in the past.
These unmanned ground and aerial sensors are part of a powerful network led by the U.S. Army Brigade Combat Modernization Team. The future plan is for the network to link directly to the Land Warrior system, but for now, it's still in the development phase.
We're looking at the first point to the network itself, which would be the unattended ground sensors. This is an urban unattended ground sensor. This is part of the tactical unattended ground sensors. This is an example of a seismic spike.
This allows a commander to maintain a presence inside an urban environment, like a home.
So these sensors provide a variety of notification that do have seismic, acoustic, photographics with the IR capability.
This soldier is part of the evaluation task force in Fort Bliss, Texas. They're conducting mock missions, learning how to operate the new technology.
These right here allow us to take pictures and let us know that people have been walking through our area of buildings that we have already cleared. If a high-value target comes in behind us, these right here will let us know, and we'll be able to move in and go ahead and be able to capture him without him even knowing.
The information captured on the sensors is then wirelessly linked to the NIC, or Network Integration Kit.
This is an 1151 current force platform, Humvee. In the back of it, we have the kit itself, the Network Integration Kit. When we were talking over there, the camera itself snapped the photograph and passed it all the way here to the Network Integration Kit.
Another device that gathers data from the air is the Unmanned Aerial System, or UAS.
The soldier will actually operate this autonomously, and this would be flown over an area that current operations are being conducted to provide that ground commander better situational awareness of what's occurring directly above him or within the surrounding areas. The camera itself is a gimbal camera that rotates. The one that's actually rotating is well above us here. While the aerial vehicle is in a hover, the camera itself can be mobile.
The camera can rotate 360 degrees.
We also have the capability to zoom in
and zoom out to provide a comprehensive view of the target zone. Weighing less than 51 pounds, it can be carried by hand, allowing soldiers to launch from just about anywhere. Its vertical takeoff and landing capability gives the soldiers the needed flexibility to get air reconnaissance in terrain that is complex or has rolling hills. Back on the ground, if a soldier needs to see inside a building where the UAS is limited, soldiers have the SUG-V, or Small Unmanned Ground Vehicle.
What the SUG-V allows a soldier to do is allows them to fulfill any kind of missions, interrogate IEDs, clear buildings, when the soldier sees an image that he wants to capture and send to the network, through the network, into the network integration kit, it's done through these cameras that you see right here. We're putting robotics in a threat environment where a soldier would normally be, and that bottom line will save soldiers' lives.
It's helped us by allowing the robot to go in first and alleviate me risking my men's lives. If there's trip wires or any kind of danger inside of the building, the SUG-V can spot it first and maneuver around it and let my squad leaders know and me as a platoon sergeant know that there's danger in that building. It's very durable. I could throw it in windows, throw it downstairs, throw it over walls.
If it lands upside down, no worries. They can turn it over with just a few quick maneuvers.
So what it's doing right now is with the flippers, the head, it's changing the center of gravity to bring it upright.
And they can do this from far away.
The distances are awesome. I'm getting anywhere from 2 to 3 Ks away from the actual equipment. It's relaying to the NIC appropriately, sending up pictures, and giving excellent data for me and my platoon to execute our missions proficiently.
These soldiers are making considerable changes, helping to improve the equipment.
Before, with the SUG-V, we had soldiers using a handle that would sometimes break or just carrying it on their shoulders. So we all sat down and came up with a good, innovative way to use a Alice pack frame with some bungee cords to quickly strap it onto a soldier's back and be able to move freely without any hindrance.
And for the soldiers who have been in war before, will this really make a significant difference?
When I was in Iraq last time, we didn't have equipment like this, and it was hard to see what we was getting ourselves into, and then when we was entering and clearing houses. With this piece of equipment, it's easy for me. I can get an actual visualize and see what we're dealing with when we enter the house.
But one soldier won't be the only one who sees what's inside. This is the TOC, or Tactical Operations Center. If the NIC is the heart, the TOC is the brain.
The image is captured in the field through any one of the 3 sensors that you saw. It's sent through the network integration kit into the Tactical Operations Center, where the key decision makers or analysts can make better sound decisions and act upon those.
Imagine a war fought with unmanned robots and aerial vehicles. Right now, they're slated to bring this technology to 7 infantry brigade combat teams by 2011. And shortly thereafter, they hope the images and data may be sent directly to the eyepiece of the Land Warrior system.
Currently, right now, we're in the developmental phase to take this network down to the soldier level.
Once upon a time, we didn't even have email. We still kick some serious ass.